I'm really excited and honored and nervous to be here, so it goes well. We'll start with just a little bit about me. Well, I was in a technological unit in the Army, and that's where I learned a lot about reverse engineering. And when I finished the Army, I decided to go into game development. And this talk is kind of a marriage of both fields, so you'll see in a bit how things I've learned in the Army service have just connected to my work today. Okay. So we're going to talk about hacking and faking high scores. And we're going to look at it both from the developer's point of view and the hacker's point of view, and how there's a back and forth, like a cat and mouse game between them. And we're going to consider how do you prevent fake high scores in your leaderboards. A lot of people here have mobile games and probably have had that problem. Okay, so let's imagine a situation, right? There's a developer and he's saving the score basically in the simplest way he can. So he saves the score locally on the phone. Say he's developing on Android, and he's using something called player preferences, which is just kind of a data file on the phone, which saves passwords and whatever settings the player has selected, and usually saves high scores. And the hacker wants to cheat at the game. He wants to have a high score. He wants to be the top of the leaderboard. So he can root his phone. On Android, it's very easy to do that. You just reinstall the software, and then he just edits that file. So there's, for example, a tool called ES Explorer, and it's just like a file explorer, just like on your computer. You go in there, you find the preferences file, and you can edit whatever values you want. This could say score, and you can write like, I have a score of 2 million points, and in Flappy Bird, for example. And people have cheated at Flappy Bird because they don't want to play it. The next step for the developer is to make this a little bit harder. So don't just save the score. He says to himself, yeah, I won't just save the score. I'm gonna save something that's gonna look strange, that maybe the hacker won't understand exactly what I'm saving. So what he can do is encode the score. Base 64 is just a common encoding, but for instance, you could just encode, if you have the score of 13, then 1 is the word tree, and 3 is the word apple, and so the score is tree apple, and whatever encoding you want to have. And you can manipulate the score, do some math manipulations on it, so it's not as easy to figure out what the right score you need to write into the XML file. And of course, this isn't that challenging for a good hacker. There is a method called black boxing, which I really like. I really enjoyed doing that when I was in the Army. Basically, you look at the software, for example, at the game, and you think of it as a black box, something that you don't know how it's working inside. But you can give it input, and you can see what comes out. So the input is playing a game. You play a game, whatever the mechanics are, you reach a certain score, and then you look in the preferences file, what was saved. Does it say tree apple? And so you figure out the encoding, right? So that's black boxing, and it involves a lot of guesswork and a lot of experience with common methods that the hacker already knows and already anticipates. So probably they will get past this defense pretty easily. But the next thing you can do is encryption. So are you familiar with encryption mostly? Is anyone not familiar with the concept? Okay, good. So basically what the developer does now is encrypt the score with some kind of secret key, and that secret key is in the app. So what you need to understand is you can't really hide anything in your app. Whatever you put there, no matter how much you think it's secret, it's there. Like, it's at the fingertips of the hacker. He can just take it out and use it. It might be hard. He might have to work a lot, but he's going to find it in the end. And another like little strange word here is obfuscator, and that's just something that you can do to the APK, to the file for your app, to make it a little harder to look inside and understand what the code is doing. And it's basically changing the names of all the functions and making it less readable. But the hacker at this point will see that he has to decompile the APK. So he's going to organize the code. He's going to look at, there are tools for this, very good tools, make it much easier to decompile and look inside the code. And eventually he's going to see, well, let's say you're using AES, which is a very strong encryption algorithm, but it doesn't matter that it's a strong encryption algorithm, because it's all dependent on knowing the key and knowing the password, and he's going to just see the password in there. So just so you can see a bit what it looks like, if, for example, one of the things you can see when you decompile an APK is all the strings in the app. So you have strings like, what do I have here? Like, yeah, this is from a game I made called Smile or Frown. So you have the words smile and frown and level, and you're gonna have the password in there somewhere if it's a string. So that's an easy way to find the password. Just a top-level view of a tool called APK Studio, used for decompiling Android apps. And here, I don't know if you can see because it's a bit small, but basically the hacker has searched a bit and he's found a function called save high score. Or maybe it was obfuscated, so it's not called save high score, but he figured out that that's what it does. And here it references the preference file, and he sees that he's saving the last score. That's where he looks for your manipulations, that's where he looks for your encryption, and that's where he's going to find it. So it seems that it's kind of hard to defend against this, but what I think the important point I want to make is you're not going to defend completely against hackers, but you can minimize the amount of people who will be motivated enough to go through whatever you're going to make them go through in a moment to achieve like this potentially not very valuable feat of cheating at your game. I mean, it all depends on how valuable it is to them. So at this point, if you really want to frustrate the hacker, you might use a non-standard encryption. You might take the code for AES or another encryption algorithm that you're using it, and you go in there and you change some numbers, and it's still the same. Like, it's still as secure and as legitimate to use it, but it's not going to work the same for the hacker when they write a script and they want to save their own scores. And this is the point, I think, that a lot of hackers will be frustrated, maybe give up. Again, if money is involved in some way in cheating your game, maybe they will still be motivated, but I think this could be a good point to stop them. Yeah, so if they do decide to attempt to overcome this, they would have to dig into the implementation of an encryption function, which is usually very complicated and long, and look for the differences between that and between your own code. Or they could use something called dynamic debugging, which I'll say is not always possible or not always easy to do. Everything is possible, but dynamic debugging means that they just access whatever data your app has in memory while it's running. So they don't even need to see the code. It's just they're just gonna change things as the app is running, as the app is sending the high score. And finally, we get to the fifth step, and a lot of apps use this, server-side defense. So if your encryption key is on the server, on somewhere on Amazon, on Google, then the hacker isn't going to see it in your APK, right? They're gonna be stuck. And this is the point where considerations of cost effectiveness and is it worth it to put the encryption on the server and make all your other players have to be online to play the game just because there's like one player who's trying to cheat. And this is always a problem in the world of hacking. Like, how do you compromise between not wanting your game to, you don't want your leaderboards to be full of 99999 scores, fake scores, and still have the game playable and fun for the other players. And a lot of games did go online because of that. And at this point, the hacker still has some things they can do. Perhaps they can use dynamic debugging, which I just mentioned. And perhaps they can try to attack the server. And server-side security is never perfect. It can be better. You can improve it. You can look for loopholes yourself and try to close them. But it's a lot of work. And sometimes you're not going to find everything. This was a very technical. I feel maybe this was too technical. But now we're going to switch to something a bit more abstract. So it's, yeah, you have a spoiler there. The heuristics approach. Basically, what heuristics means is you don't so much mess with security and trying to prevent decompiling, but you just make it really hard to figure out what is a correct score for your game. So, of course, if you see a score of 9,999, you know it's probably fake. But maybe the hacker is going to save a score that looks okay, like, I don't know, like 10,000 or 1,000, and it's the top of the leaderboard. How do you know it's fake? So you can have the score itself depend on other things in the game. For example, if your game is about collecting fruit and you collect apples and bananas, then when you collect an apple, you get 5 points, and when you collect a banana, you get 3 points. So not every score is possible, right? You can't have a score of 7. It's not possible. One thing you can do is, along with the score, you can send the number of apples and the number of bananas that the player has collected, and calculate if it makes sense. Like, is the number of apples times 5 plus the number of bananas times 3 the resulting score? It's possible that if it isn't, it's obviously a fake score. And you can complicate this more. You can have like once every 100 fruit, you get another 167 points. And so just some random number, and it's going to be harder to fake a score and not make a mistake, and then kind of mark yourself as a cheating user. So that's, how much time do I have? Oh, okay, good. So that's an approach I really like. I think, I mean, even this is going to be visible in your code, right? There's going to be a code before you save the score, and it's gonna calculate all these things. But it makes just a lot of people just want to have like the 10 million score, and if they have to figure out like what exact number they can get, maybe they will be discouraged and not as attracted to doing that. And one thing that's mentioned here is a lot of games, especially multiplayer games, they deal with cheating by constantly being online and constantly sending a status of the game. So now the players' minions are over there, and now they have this much resources, that much resources, and if you send the updates all the time, it's pretty hard to cheat and change the number of resources you have. So to sum up, the important things to take away from this talk are that with enough determination, the hacker will always win. There is no perfect security. There is no such thing. Even the most secure algorithms at some point are broken, at some point there are loopholes that are found. And as a developer and as a business person who owns a company, for both of them, it's important to realize that there's this threat and to also not be too paranoid about it. So just if you understand how the hacker thinks and what their motivation is, then it's not that much of a threat, maybe. This brings me to, so if you understand that the hacker is going to be motivated only to a certain point, then make it just hard enough so they will quit before they finish the task of cheating. And there's the issue with going always online, which I'm sure a lot of you, if you play games on the PC especially, you've experienced this. There was a wave of always online games which were trying to defend against all kinds of cheating and hacking and just stealing the game. And it's a problem for players. I mean, I hate when games are always online. On mobile, it's a much bigger problem because people are playing on the bus and suddenly they're on a train and they go into like a tunnel and they lose connection to the internet, and now they can't like play your tapping game where you collect fruit. Why does it need internet? So that's annoying, and I don't think it's worth it to harm the players. Most players experience just to have like a much better defense. That's just, but you have to consider, depending on what your game is, what's the best approach. And so yeah, choose the most cost-effective solution that fits your game. Is it multiplayer? Do you have a lot of developers who can take time to work on these defenses? Or are you a small team and you don't even plan to go that big, and it's not going to be that much of a tragedy if someone gets into your leaderboards and has a high score without playing. It's all about managing your effort to defend versus what's it worth to you. Yeah, and that's it. Any questions? And you feel free to email me also if you like.
Thank you,
and
Nataly.
You can get the slides at this link.
Thank you.